6. This asks us to find the value of the lines of x that make the line R parallel to S. That symbol means parallel. Okay, so you're going to be using the converse theorems here. All right, let's take a look at problem A here. Notice we're trying to prove parallel lines. That's why you don't see the two red triangles here. Okay, so how are these two angles related? Well, notice they're both on the inside and they're on the same side. So they're on the inside, first of all. So that is interior. Then they're on the same side. So that is consecutive. Okay. And we want to prove parallel lines. So it's the converse. Okay. The converse of consecutive interior angles state that if these two angles add up, so if they add up, if 2x plus x is equal to 180, then they're parallel. Then R is parallel to S. So for this to be possible, we have to get an x value. So 2x plus x is 3x. That gets you equal to 180. Divided this by 3, you get x is equal to 60. They said that if you let x become 60, then these two are parallel. Let's see if that makes sense. So I'm going to erase this and put the value of 60 degrees here. And then I'm going to erase this. 2 times x is 120. Perfect. Okay, let's do some filling in to double check. If this is 60, has to be 60, right? By vertical angles. Then we can get linear pairs here. So this is 120, this is 120. Ooh, look, it already matches 120 and 120. And here you know that they are corresponding. So that's how you can check that it works. Let's look at B here. Okay. Let's see the angle relationship here. Well, they're both on the outside. So we would like to write exterior. Notice this crosses, so this is your alternating. And then we want to prove parallel lines, so this is converse. So this is the converse of the alternate exterior. We know that they have to be congruent. Okay, so if they 90 minus x is equal to, because this says congruent, to x, then you can say that R is parallel to S. For that to be valid, let's add x to both sides. You get 90 is equal to 2x. Divide both sides by 2. You get 45 is equal to x. That means this is 45. This is 90 minus 45. And 90 minus 45 is 45. So yes, this works, 40 and 40 because of alternate exterior. So if x is equal to 45, then these two lines of R and S are parallel. Let's now take a look at C. How are these two angles related? Well, it looks like they're both on the inside. So we can write interior angles because they're both on the inside. And then they look like they cross the transversal, so we can say it is alternating, mind my spelling, alternate interior angles. Because we're trying to prove parallel lines, we want to make sure we write converse. So the converse of the alternate interior angle states that if these two angles are congruent, so if 2x plus 20 is equal to 3x, then line R is parallel to S. So let's see if that works. Okay, we're going to subtract the 2x because we always want to move the smaller variable first. 20 is equal to x. Oh, there you go. 20 is equal to x. There you go. If you plug it back in, it should make sense. 3 times x. X is 20. This should be 60 degrees. Then 2 times x. So 2 times 20, which is 40, plus 20, which is 60. All right? And these two are congruent. So there you go. That is how you prove that the lines can be parallel given these equations and finding an x value to make those true.